Hello everyone. So now in this particular lecture I am going to explain one of the question which was given as a homework. It was the homework for lecture number 5, okay, for class 9 science. We were studying the chapter number 1, that is laws of motion, and in lecture number 5 I have explained you how you have to solve the numericals for kinematical equations, okay, related to kinematical equations. So homework of that particular lecture, I have given one numerical to solve. So in this video I am going to explain the solution for that question. So the question is, Sherlock Holmes was running from Baker Street with a velocity of 2 meter per second. He reached the central hall in 7 minutes. If his initial velocity was 1 meter per second, find the distance covered by him. Okay, so there is one man named Sherlock Holmes. He is running from Baker Street, okay, with a velocity of 2 meter per second. So we have been provided with the velocity 2 meter per second. Okay, he reached the central hall in 7 minutes. So 7 minutes, it is nothing but time. Okay, if his initial velocity was 1 meter per second, so if 1 meter per second is the initial velocity, then this 2 meter per second is going to be our final velocity, that is small v. Okay, so first we will write the given. So Sherlock Holmes was running from Baker Street with a velocity of 2 meter per second. So it is our final velocity, that is small v is equals to 2 meter per second. Okay, he reached the central hall in 7 minutes. So we have been given with time. Time is 7 minutes. So time is now in minutes. We have to convert this 7 minutes into seconds. So we know that 1 minute is nothing but 60 seconds. So 7 into 60. So it becomes 420 seconds. Okay. So time t is 420 seconds. And we have been provided with initial velocity, that is small u is equals to 1 meter per second. What we have to find? We have to find the distance covered by Sherlock Holmes. So to find distance is represented by small s, and we have to find it. So s equal to question mark. Now we will head towards solution. Okay, solution for this particular numerical. So we know that three kinematical equations: v square is equals to u square plus 2as, v is equals to u plus at, and s is equals to ut plus half at square. In all the three equations there is one term which is acceleration. Acceleration A. So for finding the distance, first we have to find the value of acceleration. Okay, so we know the formula of acceleration: small a is equals to small v minus small u upon time t. Okay, so we know what is acceleration. It is nothing but change in velocity upon time. So final velocity minus initial velocity upon time t. So we have final velocity as 2, initial velocity as 1. So 2 minus 1 upon time is 420 seconds. So 420. So 2 minus 1 is nothing but 1. So we get acceleration as 1 upon 420 meter per second square. Okay, so meter per second square is the SI unit of acceleration. Now we have got the acceleration. So we can easily find the distance by using the third equation of motion. So third equation of motion, so it is s is equals to ut plus half 80 square. Okay, so we have to find s. What is the value of u? It is 1 into t 420 plus half into a acceleration. We have find it now, 1 upon 420 into t square, that is time square, so 420 square. Okay, so now we can take, therefore s is equals to 1 into 420, it is going to be 420 plus 420, 1 upon 420 into 420 square, so this 420 and 1 from here, it is going to be cancelled out, so we will get half into 420. Okay, so 2 ones are 2, 2 twos are 4, 2 ones are 2, and 2 zeros are 0. So we get s equal to 420 plus 210. So 420 plus 210 is nothing but 630. So therefore the distance is 630 meters. Okay, so this is the distance covered by Sherlock Holmes. So therefore we have to write the conclusive statement: distance covered is 420 meters. Okay, so this is the solution for your lecture number 5 homework. Okay, thank you.